Lesson 7-2, Proportions. In this lesson, we need to be able to solve problems using proportions. The basic definition of a proportion is any two ratios, so let A, B be a ratio, and then we'll say C and D are a ratio. Any two ratios that are equivalent, that are equal. And if I have one ratio equals another ratio, I can solve for this, or I can rewrite this by cross multiplying. That is where you do A times D equals B times C. Let's start with an easy one. If I want to solve this proportion for x, I'm going to do so by cross multiplying. So I need 18 times 39, which I believe is 702, x. 13 times 36 is 468, I believe. And now this is just a regular equation that we've learned how to solve in Chapter 3. I'm going to solve for x by dividing by 702. When I reduce this fraction, I'm going to end up with 2/3. That is the value for x. This next proportion is going to be a little bit more difficult just because of the cross multiplying. I have two fractions with an equal sign, but if I look at this right here, if I want to multiply those two, this numerator with this denominator, I need to do so remembering that about the distributive property. Okay, it's 6 times both of these. Same thing goes here, equals 4 times 5n plus 3. So if there are multiple terms in a numerator denominator that you're multiplying with, make sure that you're distributing. All right? Now I just need to go through and solve this equation. Distribute. This is going to be 20 n plus 12. I'm going to collect all my terms on one side, so I'm going to subtract 20 from both sides. 10n minus 18 equals 12. Add 18. (10n) equals 30, which would make n equal to 3. All right, next group of problems we need to talk about is what if you're not given two fractions? Is this, what's given in front of us, a proportion? Well, this is a fraction, and then I have the equal sign, but this thing is not a fraction. But the nice part about fractions is that anytime you have a whole part, if you think of a whole number like 4, you can put 4 over 1. Same thing goes with variable expressions like this. I can just put it over 1. Now I can see my cross multiplying. So I have 4 times 1 is just 4. And then my set in parentheses. And I have 13 times negative 1, so I'm going to make that negative 13 over x plus 5. Now I just need to distribute and solve. 8x minus 44 equals negative 13x plus 5 times 13, I believe that is negative 65. I'm going to now gather my x terms on one side by adding x, or 13x to both sides, excuse me. So I have 21x minus 44 equals negative 65. Add 44. And I'm going to get that 21x equals, this is 21, so x must be 1. All right, Finally, a word problem that deals with proportions in this section. Every single one of these problems on page 296 should be able to be written as a proportion. So we just need to figure out what fraction we know and what part of this fraction is our unknown. So let's read through the problem. A car sold for $11,800 has a sales tax of $767. How much does a car cost if its sales tax is $637? The first fraction that I'm going to set up compares two quantities that I absolutely know about. And I know that a car sold for this amount has this sales tax. And 767. What I don't know, though, is the cost of the other car. And now I need to make sure that I'm going to line up my numbers correctly. If this is cost of a car, that means this is my unknown. If this is sales tax, that means I must be given another number that represents sales tax, and that's the 637. So notice I have one fraction of my known quantities that I am comparing. The 11,800 compares to 767. And then I have another fraction of my unknown compared to one piece of the given. But along this side, from here to here, these line up because they're both sales tax. These line up because they're both cost of a car. Now I can do my cross multiplying to solve. And I need my calculator for this one because it's quite a big number. 11,800 times 637 equals 767 times x. This number is quite large, but that's okay because I'm going to divide it by another big number here. So now if I divide by 767, I get 9,800. And that seems a reasonable answer to the question, seeing as this car was $11,800. For a car to be $9,800 is about in that ballpark. And this tax was bigger than this tax. Make sure in a word problem that we're including the label into the answer. So we're looking at $9,800.